Hello, Assalamu alaikum, dear students. Today we are going to discuss the most important part of the building components, that is footing or foundations. Basically, what is the function of a footing? It transfers the load which is coming from the slab, beam, column to the footing, and footing will transfer the load to the soil below it. So that is why here first we'll know what is the definition of the footing. Basically, what is the function of the footing? Support structural member and transfer load to the soil. So this is the main function of the footing. We support the loads which is coming from the structural member. Structural member, you can say that is a slab, beam, column, and whatever the load which is coming from the slab, beam, column to the foundation, then the foundation or footing will transfer the load to the soil. Structural member are usually column and walls. I already explained. Designed for load to soil uses unfactored load. Structural design for footing is done with the factor loads. So here we were calculating the factor load just multiplied by the factor of safety with dead load. As earlier we calculated the total W is equal to 1.2 multiplied by dead load, 1.6 multiplied by live load. But if you are going to find out what are the dimensions of the footing, we will take unfactored load. We will not multiply the load with the factor of safety. But when we are designing the structural that is the footing, then we have to take the factor load. Generally, footing must be designed to prevent the bearing failure, sliding and overturning. Footing must be designed to prevent excessive settlement or tilting. Typically, the bottom of the footing must be located below the frost line. Means the bottom of the footing should be at the hard strata of the soil. Excavation may be required to reach a depth where satisfactory bearing material is located. So suppose if there is a filled up soil, then you have to excavate the soil where till now when we'll get the hard strata of the foundation, then we'll keep our foundation to the hard strata on the soil. Generally, there are two types of the foundation or footing. That is, one is shallow footing and another is deep footing. Shallow footing means if the depth of the footing is less than twice the width of the foundation, then we can call as shallow footing. And foundations, or when the depth of the footing is more than 2 times the width of the footing, then we will call as that is deep footing. All footing now we are going to discuss. Basically, this is a shallow footing. In shallow footing, there are first footing is wall footing. Wall footing, enlargement of the bottom of the wall. So this means this is wall, and this is the footing of the wall, and the wall may be 10 meter, 20 meters, whatever. It is a continuous footing. So you can say this is the wall footing. So you have to design this wall footing, and it comes under the category of the shallow foundations. Then the second footing, that is isolated square footing. This is the footing of a single column provided in a square shape, or isolated square footing, or isolated rectangular footing. It depends on if the size of your column is rectangular, it is better to provide a rectangular footing. If it is your size of this column is a square, it is better to provide a square footing. So this is also comes into the category of the shallow foundations. Now there is a combined footing. Suppose sometimes what happens if the spacing of the column between the column is less. If we calculate the area of the foundation for this column and area of the column foundation for this column, if there is overlapping, there is no large space between the column. If there is overlapping, then it is better to provide the one footing for both columns. That is known as combined footing. Combined footing means it is the foundation of more than 2 columns, maybe 3 columns, 4 columns, 5 columns. If it is in one direction, the direction is not changing. In X direction, whatever the columns you are provide one footing for maybe more than 2, 3, 4, 5 in one direction, then you can call as combined footing. It is not necessary for combined footing. We can say only 2 columns. 2 columns, 3 columns, 4 columns, 5 columns in one direction. If you provide in one footing for all columns, then it is known as called combined footing. Now the next one is the mat footing or a raft footing. Continuous concrete slab supporting many columns, soil strength relatively low, large column load, isolated spray footing would cover more than 50% of area, reduce differential settlement. This type of footing were provided when there is a filled up soil and the large load acting on the column and spacing of the column is less, and when we calculate the foundation of each column, if it is if we add it or foundation of all column, if we add it, if it will be more than the 50% area of the total your land, then it is better to provide a raft footing, that is the one footing for all column here in this x direction as well as in the y direction. If it is in x direction, then it will be a combined footing, because here the direction is changing in x direction as well as the y directions. So this means we can call as this is raft footing. That is why it is telling here that if the bearing capacity of the soil is low, where the maximum load is acting, large load is acting on the column, and the combination of, if you combine the area of the footing for all column, if it is more than the 50% area of your building area, then it is better to provide a mat footing. Now the deep footing, that is the pile footing or a pile cap. Pile cap distribute the column loads to the group of pile. So this is your group of pile, this is pile cap, and this is the column. So suppose if the depth of the footing is more than the twice of the width of the footing, then you can provide pile footing. Or for pile footing, it is very necessary to provide a pile cap, because the load from the column will come to the pile cap, and pile cap will equally distributed on pile which is connected to the pile cap. So generally the pile is provided when we are not getting the that is the bearing capacity of soil good at a minimum depth. This means if the soil bearing capacity of the soil is very weak and the problem of differential settlement, and then we cannot find the hard strata, we'll find maybe up to 12 meter, 13 meter, 40 meters which is going down, then you have to provide a pile foundation. Or for pile, maybe it is a group of pile, it is a single pile, it is a 2 pile or 3 pile, and if it is providing 2 or 3 piles, so you have to cover with the pile cap, and then pile cap connected to the column. The column, the load coming from the column, it will go to the pile cap, and pile cap will transfer the load equally on the piles, and the pile transfer the load due to two actions. One is due to the end bearing, and one is due to the friction of the soil as well as the pile. So this means there are two types of the pile. One is friction pile and one is end bearing pile. If the pile transfer the load due to end bearing, then it is known as end bearing pile. If the pile cap piles transfer the load due to the friction, then it is known as friction piles. So we already explained that is there are two types of the foundation. There is the shallow foundation and deep foundation. In deep foundation, all foundations are shallow foundation. In deep foundation, you can say there is a pile foundation or a well foundation, which is not explained in this course, and then we'll maybe in other time we can explain. I can explain the well foundations also. Now the soil bearing capacity. Soil pressure. So this means if the load which is coming from the column, and column transfer the load to the footing, and footing will transfer the load to the soil. So soil means it will exert a pressure upward from the soil. So soil pressure is assumed to be uniformly distributed beneath the footing if the column load is applied at the center of the gravity of the footing. Footing supported by sandy soil, footing supported by clay soil, footing supported by eccentric load. So this means there may be a different kind of soil where the footing is supported. If footing may be supported by sandy soil, in Saudi Arabia there is a sandy soil, but in other countries may be the footing supported by clay soil. So only the pressure distribution diagram, the upward pressure exerted by the soil to the footing, it depends on the type of the soil. So we are assuming that the soil pressure which is acting, suppose this is the column load, and column load will go to the footing and footing will transfer here, and this is the bearing pressure exerted by the soil. So this means if the pressure here column and this is equal, then your footing will be the safe. And this is the diagram for the sandy soil, which is more pressure at the here and at the center of the column, and the less pressure is here. And in clay soil the pressure is opposite other than the sandy, but for designing purpose we are using the uniform pressure which is acting on the soil, which is acted by the soil on the foundations. Then we have to calculate what are the allowable soil pressures. Actual soil pressure is based on unfactored soil. So this means if we are calculating the soil pressure, we have to calculate based on unfactored load. We will not multiply the factor of safety to the load. Allowable soil pressure may be determined by geological engineer when the soil exploration is not feasible. Values provided by the building codes may be used. So this means we are getting a reliable source, and then the soil bearing capacity, we are getting the exact value, more or less exact value. So this means we are not taking any factor of safety for calculating the pressure, allowable soil pressure which is acting on the soil. The factor of safety for the designing of the footing will take as 3. So these are the allowable soil pressures, the different of the materials soil here, and these are the allowable soil pressure is here. Now after the next slides I will explain what are the design criteria for the wall footing. Thank you very much.